Let us derive the equation for voltage across capacitor in a driven RC circuit where the RC circuit is driven by a DC source. So the circuit can be one resistor, capacitor in series and a DC source. R, this is the source Vs, capacitor C, and this switch T is closed at T equals to 0. It is called as driven RC circuit because at T equals to 0 there is a DC source. At T equals to 0 there is a source. Here in this case we are taking DC source. Due to DC source, we can say that it is the step response of the RC circuit because this circuit can be redrawn without switch and multiply the Vs with u of t. U of t is the unit step function. So we can write Vs u of t. Now this circuit will have only the source Vs when t is greater than 0 and equal to, because source is multiplied with ut. U of t is the unit step function. It has the value 1 for t greater than equal to 0. Okay. The similar way we have applied the KCL in source free circuit. Here also we will apply the KCL for source driven circuit. Consider this as a node where the voltage across capacitor is Vc. So the node voltage is Vc. The current flowing in these two sides we can consider IR and IC. Okay, this is the node. So voltage across this is Vc. So node voltage is Vc. So let us apply the KCL. IC plus IR equals to 0. Now IC is the voltage through capacitor. We will take it as C dVc by dt. Okay, plus now IR, the current through resistor. While applying the KCL, this current will be voltage drop across resistance divided by R. So voltage drop across resistance will be Vc minus Vs ut divided by R equals to 0. Okay, now since u of t is equals to 1 for t greater than equal to 0, what we can do? We can rewrite this equation C dVc by dt plus Vc minus Vs upon R equals to 0, and then say t greater than 0 because we have to find the response of this circuit for t greater than 0. Now simply rearrange the terms and separate the variables. So we can separate this Vc terms. We can take separately Vc by R, C dVc by dt minus Here it will be plus Vs upon R equals to 0. We can divide the complete equation by C and we can have dVc by dt plus Vc by Rc minus Vs upon Rc equals to 0. Now we will keep these terms Vc by dVc by dt here and take both other terms on the right hand side, Vs upon Rc minus Vc upon Rc, and then we can also do this. Okay, here we have to take minus sign outside, take the common minus, and 1 upon Rc we are taking outside, so inside there will be Vc minus Vs because we have taken minus sign also common. Now we have to separate the variables, so we will, on the left hand side we will keep Vc dVc upon Vc minus Vs equals to minus 1 upon Rc multiply. This dt will go on right hand side and Vc minus Vs will come in the denominator of left hand side. Now we have to integrate. Simple steps. We have separated the variables. Now we have to integrate. After integration we will find the constant of integration. Now left hand side it is to be integrated with respect to Vc, and on right hand side it will be integrated with respect to t. After integration we will get ln Vc minus Vs equals to minus 1 by Rc t plus k, where k is the constant of integration. Now find k. To find k at t equals to 0, we have to put Vc equals to V0. This is the initial condition. We assume that the capacitor is charged. That means capacitor is charged at t equals to 0 and the voltage at t equals to 0 is V0. This is the initial value or initial condition. So put this in the equation 1 and you will get ln Vc of 0 is V0 minus Vs equals to minus 1 by Rc, t is 0 plus k. So we can say that k equals to ln V0 minus Vs. Substitute this k in equation 1. Put in equation 1. So it will become ln Vc minus Vs equals to minus 1 by Rct plus ln log. Okay. Now what we need to do, rearrange the terms. Logarithmic terms we will take on left hand side. Now left hand side will become ln Vc minus Vs log of this and divided by V0 minus Vs equals to. Now to find Vc, the equation for Vc, we will take the antilog. After taking the antilog, left hand side will become and right hand side will be e to the power minus 1 by RC t. Now we have to solve it for Vc, voltage across capacitor. So let us solve it. Vc minus Vs equals to V0 minus Vs e to the power minus t by RC, I can write, and finally the voltage across capacitor will become Vs plus, this Vs will go on right hand side, V0 minus Vs e to the power minus t by RC for t greater than 0. So this is the equation of voltage across capacitor for t greater than 0 in a driven RC circuit when the circuit is driven by DC source. Very important. It is called as response, free step response also. Here again the RC is nothing but the tau, which is called as the time constant. If you can see that at t equals to 0, in this equation we keep t equals to 0, this term will become 1 and Vc is equals to Vs plus V0 minus Vs, that is voltage across capacitor is the initial value of the initial voltage across the capacitor, right? And at then it is exponentially varying, okay, and then it will reach to Vs. So let us see at t equals to infinity, Vc is Vs plus V0 minus Vs e to the power minus infinity. The value of this is become 0, so it will become Vs. So at t equals to 0, the value across capacitor is V0 and t equals to infinity, the value across capacitor is Vs, right? It means from t equals to 0 it is exponentially changing and reaching up to Vs. So let us plot its response. Suppose these two voltage levels, okay, we are considering that V0 is less than Vs. This is the capacitor voltage, it is at 0. So at t equals to 0 it is V0. So capacitor will start charging here and Vs is greater than V0, then it will charge exponentially and reaches up to Vs when it is t is infinity. Now just tell me, what if V0 is less than Vs, then what will happen? Vc here, V0 here, Vs, then this will exponentially decrease and reach to the Vs. So just understand the concept. This is the response of